Hello everyone. Today we're going to learn how to solve exponential equations. Okay, for our warm-up guys, I want you to go ahead and pause the video and give these a try and find out what is the exponent that makes this equations true. So go ahead and pause the video and give these a try. Okay. Alrighty. So from here, hopefully it wasn't that bad. I know we are familiar with our skills from middle school where we were able to do a factor tree and be like, oh, 4 times 2 gives me 8, and my 2 is the same thing as saying 2 times 2. And hopefully you're able to see that 2 times 2 times 2 is 8, right? So we're trying to find out what makes that true. Well, keep in mind, 2 times 2 times 2 is the same thing as saying 2 to the third. Okay, so that all of that was for the left-hand side, and my right-hand side was 2 to the x. So we can probably see that, hey, what is that here missing on the basis of 2? Well, it's x equals 3. Now keep that in mind. Some of us might have known that from just our memorization or doing these a lot. We know that x would have equal to 3. So whatever method you are familiar with, whatever method you are comfortable with, works for this. So let's go ahead and see if we can do the next one with memorization or based on what we already know. So 100 equals x to the y. So what is our y? Well, hopefully you're familiar that 10 times 10 or 10 squared is equal to 100. So my y is equal to 2. Okay, let's go ahead and try the next one. 27 equals 3 to the w. So what would that w be? Well, right here we can see that w should be 3 because 3 times 3 is 9 and 9 times 3 is 27. Okay, so my w in this case is 3. So 3 to the third is 27. Okay, so hopefully that was not that bad. Okay, let's go ahead and try a couple more examples. So looking at this week at a glance, today we're on Wednesday, hump day. No, I'm just kidding. And that our homework for today, the 3.4 is due. We do have today's homework will be due on Friday. And keep in mind on Tuesday, we got our ACT exam, if you did register for that. And then on Wednesday is our Unit 3 exam. Okay, so busy week next week, right? And I believe Friday we're off. I'm not sure. Can't remember. Okay, so let's go ahead and start on today's lesson, and we want to go ahead and learn how to solve exponential equations using properties of exponentials and logs. Okay, so let's go ahead and begin. I am going to go ahead and ask you guys to pause the video right here and write down these notes. So pause the video and give these write these notes down. Okay, so you're probably like, what the heck did I just write? Well, good question. So pretty much what I want you to know is that whenever you are working with an exponential functions, exponential equations, and they have the same base, so let's look at these bases right here, and let b be a number. We have b's to be numbers that are the same. All you have to do is get the exponents, right? The exponents to the same basis and set them equal to each other. So from here, all I had to do was saw that these were the same base, so I got the exponents to be equal the same. Does this work for logs? Well, if the log has the same base, meaning it is a log with the same base as well, so if this right here is the same and this right here is the same and they're an equation, all you have to do is pretty much the same thing. You're trying to get the inside of the logs to be equal to each other. Okay, so let's go ahead and see this in action. So let's go ahead and try the first example. So go ahead and pause the video and give number 1 a try. Okay, so I have 4 to the x equals 16. So just based on what we saw, we can either do the factor tree or we can try to rewrite them. So I'm going to go ahead and focus on trying to rewrite these. So I have 4 to the x. Okay, there's no way to rewrite that. It's just 4 to the x Unless I go a number down, but let's not do that. Okay, how about 16? Is there a way to write 16 in a base of 4, right? In a base of 4. So you're probably thinking to yourself, 4 to what power gives me 16? So what would that number be? So hopefully you remember from the do now, this would be x equals 2, right? Because my basis, right? My base 4 is the same. So I'm going to set exponents equal to each other. So that's my way of saying exponents equal to each other. So my solution will be x equals 2. Okay, let's go ahead and give the next one a try. Pause the video and give this one a try. Okay, now I have 9x and equals 27. So you're probably thinking to yourself, hey, Piscina, I have no idea how to make a 9 multiply to itself to give me 27, because if I square it, it gives me 81. That's a good observation. So this is one of the cases where we couldn't. However, if we look at a base, at a factor they both might have. So let's think about the factors that make up 9. So 1, 9, and 3 times itself. So let's see if the base of 3 works. Okay, so keep in mind, you're pretty much looking for a factor that multiplies to itself to give me 9. So this should be a 3 to something, and this should be a 3 to something, right? So something that gives me 9, right? Keep in mind, this 9 came with an x, so I'm going to go ahead and have that x right here, okay? However, 3 to what number gives me 9? We're still missing that part. Well, keep in mind of our numbers, we should be aware that the number that's going to go right here should be a 2, right? So 3 squared gives me 9. So this number should be a 2. Okay. How about the number 3 to what number gives me 27? So what number will go here? So think about what we just did. We have 3 to some number will give me 27. And if you remember, that should be a 3. This should be 3 to the third gives me 27. That should be the number that goes right here. So therefore, I have all of this. I have 3x to the second equals 3 to the third. So now that I have the same basis, I can do what to these exponents? Let me write that down. So we have same base, right? The same base, the 3 is right here. So we're going to go ahead and get the exponents, and we're going to go ahead and equal them to each other. So in this case, x times 2 equals 3. And we can go ahead and solve for this. This isn't that bad. X is being multiplied by 2, so I'm going to get rid of that by dividing by 2 on both sides. So x is equal to 3 halves. Okay, hopefully that wasn't that bad. So let's go ahead and go with the next one. 10 raised to the x equals 1 over 100. Keep in mind, this right here is going to go ahead and use the property of the reciprocal, which tells us that if for some reason you have an exponent that is a negative number, well, a negative 1 in this idea, is going to go ahead and make it go to the denominator. So it's pretty much the reciprocal of it. So keep in mind, if it's a negative 1, it'll drop that base to the denominator. If it's a negative 2, it's going to drop the base to the denominator and square it. If it's negative 1,000 on the exponent, it's going to drop down the base to the denominator and then have it raised to the power of 1,000. Okay, so the first thing we want to go ahead and do is find the base. What base do these two have in common? So hopefully you're able to see that on the left hand side I have 10 to the x, and on the right hand side I have 1 over 100. So I'm going to go ahead and think that my best bet is to get the base to be equal to 10, right? Because I know what 10 is, and I'm pretty sure I can get a 10 to some exponent to give me 100. So 10 raised to the x is equal to 10 raised to some number is going to give me 1 over 100. So let's think about that real quick. I'm going to go ahead and think out loud for you guys. 10 raised to the second gives me 100, but I don't want 100. I want 1 over 100. I want 1 over 100. So therefore, it must be 10 raised to the negative 2, because the negative drops my base to the denominator. So this has to be a negative 2. So my solution, right, now that my bases are the same, my solution, when I said my exponents equal to each other, my x is going to equal to negative 2. That will be my solution. Okay, let's go ahead and try one a little bit more challenging. So go ahead and pause the video and give this one a try. Okay, so keep in mind this identity right here that is a reciprocal, so I'm going to go ahead and write that out. Okay, so if you forgot about that, go ahead and pause the video one more time and try it again. If not, we're going to go ahead and continue. Okay, so I have 1/2 and I have 8. So what I want you to know is that there should be a certain value that both of these can have the base, right? The base of. So for me, I'm looking at them and they look even. Well, they're both divisible by 2. So I'm going to go ahead and say my best bet is 2. So I'm going to go ahead and say 2 is going to be my base, right? My new base, right? It's going to be 2. However, this one right here came with an x. So I'm going to go ahead and bring that here. My 8, I remember I'm going to convert it to something to go ahead and give me this 8. But keep in mind, it came with an x minus 1. So I'm going to go ahead and drop that down, x minus 1. Okay. Now, I am not done here. I just brought down these, but I still need to make my 2 equal 1/2. So I'm going to go ahead and think to myself, 2 raised to some number, right? That's going to go right here, raised to some number, is going to give me 1/2. And that's where this identity comes in. 2 to what number gives me 1/2? Hopefully that was not that bad. This should be -1. So this right here is -1. Okay, let's go ahead and try the next one, the right-hand side. I have 2 to a number. It's going to go ahead and give me 8. And that's going to go right over here. So keep in mind, the 2 raised to the x came from the left, and the 2 to the x minus 1 came from the right. The only thing we have not accounted for are these numbers right here. Okay, so that's where I'm doing this right here. Okay, so on the right hand side, I need 2 raised to an exponent. That gives me 8. Hopefully that's not that hard. We did it on the do now. 2 raised to the third is 8. So this right here is to the third. Okay, so now I have the same bases, right? In this case, 2. So I'm going to go ahead and get my exponents equal to each other, right? So I'm going to have negative x, right? Because -1 times x, and 3 times x minus 1. Okay, from here, all we have to do is solve for it. I'll do it in black. So negative x equals this 3 distributes to the x, so it gives me 3x. And that 3 also distributes to -1, giving me a -3. Okay, easy peasy. All we have to do is subtract to solve for our x's. I'm going to move all my x's to one side. So I should have negative x minus 3x. That is a -4x. And this -3 just drops down, so equals -3. Okay, almost done, almost done. We have this -4 being multiplied, so I'm going to go ahead and divide by -4, divide by -4. X is equal to, the negatives are both on the numerator and denominator, so I'm just going to stay positive, and my value will be 3/4 as my solution. Okay. So this one was a little bit more challenging. I agree with you guys, but it also has more of the ideas. But if you do have questions, drop them in the comments or send me an email or Teams chat. Okay. Let's try one more. So changing the base for this example as well. So go ahead and pause the video. Think about what base you will need to change the left and the right to become, okay? So pause the video and give those a try. So again, for me, I went ahead and saw that these were even. So therefore, I'm gonna go ahead and say that they're gonna go ahead and be a 2 is gonna be one of the least common factors, right? Or the least common factor. Okay, so keep in mind this one had some exponent originally, so I'm gonna go ahead and bring that down. Does not affect me, and I'm gonna leave a space for what the exponents will be, right? Because you still need to account for this 1/2 and this 4, right? Because 4 does not equal 2. But it could if it was raised to an exponent. So let's go ahead and do that. I'll do it in red. So 2 raised to some number is going to give me 1/2. And you're probably already tired of this because you know it so much. 2 to what power brings the base of 2 to the denominator. And hopefully you're able to see that because of the identity that says that if a is raised to -1, it is 1 over a. So not that bad, right? This was a -1 right over here. The next thing is, how do I make 2 raised to a number become a 4? So hopefully that's not that bad either. And you're able to see that the number that should go here, where is it? Should be a 2. 2 raised to the second gives me 4. Okay. So now this is huge. We got the same base, right? We got the same base, right, of 2. So therefore, right, therefore we can go ahead and set the exponents, right, to each other. So on the left-hand side, I got 2x times -1, and on the right-hand side, I got 2. And all I have to do is solve for this. So I'm going to go ahead and see that 2 times -1 is -2x equals 2. And all I have to do is solve for this by noticing that it is being multiplied by -2, so I have to divide by -2 on both sides. So x is equal to -1. So the way I think about it, especially on this, it might be funny, but I think about it like 2 pizzas divided by 2 people. How many pizzas does each person get? So one pizza per person. And keep in mind that the denominator was negative, so it went ahead and stayed negative. Okay. All right. What if for some crazy reason you can't find the common base? And that's gonna happen, guys. Let's say you have 3x is equal to 31, right? And you're like, hey, I have no idea how to do that. It's probably gonna be a fraction. It's gonna be doing something else. So I'm gonna go ahead and teach you guys how to use logs to go ahead and save you some time and a different way to find that same solution. So go ahead and pause the video and give this one a try. Alrighty. So what we're gonna go ahead and do is the following. Oh yeah, so the way you do this is you can't find the common base, right? So you're gonna go ahead and introduce logs on both sides of the equation. Whatever was given to you will be left inside the parentheses, and you're gonna go ahead and solve for x using the power rule or either compressed or any of the following, right? So let's go ahead and see that so you can see that it's not that bad. Okay, so go ahead and pause the video to write down these examples. And you might not be able to see it because my video's on there, but remember there is a rule for our coefficients that tells us that if you have a coefficient, it can become your exponent. So don't forget about these rules, that if you have an exponent, a coefficient, that can become your exponent. Okay, so keep this in mind, the power rule. Okay, so let's go ahead and do 5x equals 300, and let's pretend we tried really hard to find the same base, but we couldn't do it. So what we're gonna go ahead and do is we're gonna go ahead and introduce logs on both sides. So I'm gonna go ahead and say log of the left-hand side, all of the left-hand side, so 5x is equal to log of the right-hand side, which it was 300. Okay, then I'm gonna go ahead and use the power rule, which tells me that there is a exponent right here that can become the coefficient. So now I have 5x log 6. Whoops, let's make that bigger. 6 equals log 300. Okay. All you have to do now is solve for x. Solve for x. Okay. So I'm gonna solve for x, meaning everything that does not include with x is gonna go ahead and be thrown to the other side, right? So what do I mean by that? Well, keep in mind this 5 is being multiplied to the x, and this x is being multiplied by the log of 6. So I'm gonna go ahead and divide by 5 and the log of 6 on both sides. Okay, so we can see that I got 5 over 5, so we can go ahead and get rid of that. And we have log of 6, and we can go ahead and get rid of that because they will equal 1, right? Because remember the pizza example, 2 over 2, right? It's the same on the top, same on the bottom. Okay. All right, so these went ahead and equal to 1. So I was left with x equals the right-hand side, which is all of this good stuff right here, which says log of 300 divided by 5 times log of 6. Okay, this should be our solution. I do have another example right here, so I'm going to go ahead and try that one too. But if you do have questions about this, same thing, drop it in the comments or send me a chat message and I will help you. Okay, the next one right here, what I want you to know is before you start introducing logs, guys, it's always a good idea to reduce this. I have an 8 on the outside and I have a 12 right here. So I'm going to go ahead and divide by 8 on both sides to help me reduce stuff like this. So now I have 10, 3x is equal to 12 divided by 8. I'm going to try to reduce this by dividing by, let's say 4. So I'm going to get 3 on the numerator. And if I divide the numerator by 4, I'm left with 2. Okay. So can we find the same base? Well, here's one of the perfect examples where we're like, oh snap, it doesn't work. So we're going to go ahead and find the ln. So let me see if I can. Sorry about this. It's going to be very messy. So it's going to be ln or log. They're both the same, right? Just base of e, right? So the ln of 10, 3x is equal to ln, you have to do it to both sides, guys, of 3 halves. Okay. Same thing goes, you get the exponent to become the coefficient. So I have 3x, let me just keep it consistent, ln of 10 is equal to ln of 3 halves. All we have to do now, guys, is solve for x. Okay. So I'm going to go ahead and divide. Whoops, I'm going to go ahead and divide. It's right over here. 3x ln of 10 equals ln of 3 halves. So I'm going to go ahead and divide by 3 times ln of 10. 3 by ln of 10, right? So I'm left with x equals all this good stuff, 3 halves, over 3 times ln of 10. Okay, that's your solution. Keep in mind, I would leave it like this, guys, because if you try to put it on your calculator, it'll give you some decimals. Okay. For today's meme, I went ahead and have this one, so hopefully you guys really like it. This is mostly meant for my live class because it tends to be like laggy at the most important part. So this is what how my class feels like. Okay, but now I'm back on campus, and hopefully so far I haven't heard any statements about it being laggy, but I'm not sure. Okay, 3.6, guys. 3.6 is already given to us on our Teams assignments, so it's not that bad, guys. I just pretty much similar examples, and I went ahead and moved stuff around some of the numbers so that I can be a little bit more challenging, right? But please have this completed by Friday at 5 p.m. Friday. Okay. Other than that, guys, I'm available on chat. I'm available on Teams and on email or in this comment section. Okay. Other than that, guys, I really appreciate you guys taking the time to watch this video, and see you on the next one.